In this chapter, we will be solving systems of equations. In this lesson, we'll be solving systems that are both linear and quadratic.
All right, hi everybody. So we're going to take a look at solving systems of equations and inequalities, okay? And this is something that we're going to build on where you have seen this before, okay? We talked about this in a previous course. All we're doing is going to extend this a little bit further, what you already know. So remember, what we're doing is we're looking at multiple equations, and we're looking at where they are true simultaneously. The point or points where both equations are true simultaneously. So just to kind of recap here, remember what a linear equation is. It's going to be in the form y equals mx plus b, or at least it can be written in the form y equals mx plus b, where m is your slope, y is b is your y-intercept. And then you've got a quadratic function, okay, which can be written in the form y equals ax minus p squared plus q. I mean, we've spent a fair bit of time in this particular course looking closely at that, okay, graphing it, and whether it's in the vertex form or it's in the standard form there. So what we're going to do to start off with is we're going to create a system of equations that's both linear and quadratic. In other words, one of our equations is going to have a degree of 1. The other one is going to have a degree of 2, and we're going to look at solving systems of equations that look like that. Now remember that a solution to that system is going to be a point that satisfies both equations, all right? Keyword there being both equations. That's what the solution is. Now that could happen a few different ways. When we took a look at that when we were looking for linear and linear systems in our previous course, we're going to do a similar sort of thing right now, but the way they interact is a little different. Okay, when you've got an equation of a line and a parabola, there are 3 different ways that those things can interact. One of them is for that line to go straight through that parabola, and you're going to get 2 points where they intersect. In other words, there's going to be 2 solutions to that. Or, okay, you can have that one line sliding along and it just touches the parabola right there at one point. So there, it's tangent to the parabola right there. And that's going to give you one solution. Or the line doesn't even hit the parabola, in which case there's no solution. Now, I want you to think about that, okay? And think about how this would look if we rotated that line so it's horizontal. So it's a horizontal line, we do this. Horizontal line, we do this. Horizontal line, we do this. Doesn't that remind you of when we looked at the nature of the roots of a quadratic equation, where you hit the x-axis twice? That's 2 distinct real roots. You hit the x-axis once, that's 2 equal real roots. Or you don't hit the x-axis at all, 2 non-real roots. So this is like our discriminant being greater than 0, our discriminant being equal to 0, or our discriminant being less than 0. Now, I realize that we're looking at a slightly different situation here, but man, does it ever feel similar to that. And actually, you're going to see in a little while here where I'm going to use that discriminant to give us a sense of what's going on here, okay? To give us a little bit of insight as to how the system of equations is behaving. All right, so now to start off with, before we get into the algebra of this, we're going to do this graphically. Okay, you should be able to use your calculator to solve these sorts of problems first. And so what we're going to do is we're going to enter both equations. We're going to solve both equations for y, and then we're going to enter them into y1 and y2 on the calculator. Okay, that's at this point here, that should be something you've done repeatedly. Okay, you're going to have to look for those points of intersection. Now this part here can be, well, I should say these two. These parts here can be quite difficult here. Adjust the window settings if necessary. Okay, I've watched students struggle with that. Okay, with how to put the window settings so that you can see the points of intersection. For some people, it's really not that obvious. Okay, hopefully as we go through a couple of examples, it'll help with that. But you might have to adjust your window settings to see the points of intersection. Okay, and then what you're going to do is you're going to find those points of intersection by typically pressing second trace, and then you're going to use the intersect feature. And you're only going to be able to do this one at a time, okay? You're only going to be able to do one of those one of those points of intersection at a time. And then really what you should do here is you should verify your solution by substituting those coordinates back in just to check that you actually got that correct there, okay? Anyway, determine if there are any points of intersection. These should probably be written in a slightly different order there. Adjust your window settings to see the 2 points of intersection, or to see the points of intersection. Then you're going to use the calculator to find it. Oh, now I'm going almost off there. There we go. Anyway, adjust your window settings to see the points of intersection, find them using second trace intersect, and then you should verify. Okay, let's take a look at some examples. All right, so here we're going to solve a couple of systems graphically. So that means using the calculator here. So take a look at what we've got here. Y is equal to x squared minus x minus 12, and then 2x plus y is equal to 0. Now, this one is okay because y is equal to, and remember, when you're going to plug something into the calculator, I need it to be y equals. So here, equation 2, I need to bring that 2x term over. So I'm going to subtract 2x from both sides. So here's the second equation I'm going to enter in. Okay, so now let's pull out the calculator here. So I'm going to press y equals to get it into this screen right here so I can enter my equations. X squared minus x minus 12, and then negative 2x. Bear in mind when you do that, put the negative in the front here. It's this button, not the subtraction button. So I'm going to negative 2x. Okay, now I'm going to graph that. There's my first one. And there we go. Now, the maximum number of times that a straight line can intersect a parabola is going to be 2. I can see both of those points of intersection on the screen, so I really don't have to adjust anything. So now I will press second trace to get into the menu where I can do some calculations on the screen, and I'm going to look for the point of intersection, so I'm going to use intersect. Now, I've got to take a look at my point here. I've got the point negative 0.45, negative, so I'm down here. So I'm just going to move to the left. There it is. And what I'm going to do is I'm going to find this point of intersection here. Now I'm just going to move my cursor close to it. The calculator is asking, am I on the first curve? And the answer is yes. There's only 2 curves that I entered in, and that was the first one. So I'm going to press enter. It immediately jumps me up, straight up or down, or whatever the case may be, to the second curve that was entered in. It's asking, is this the second curve? The reason it's doing that is because you can have graphed up to 10 different functions here, and it just simply needs to know. In fact, actually, you think you can even have more than that if you use the statistical features. It just needs to know what it is that you're referring to. So yes, that's the second curve. Now it's asking, can it use negative 3.636 blah 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 as a guess? Because what the calculator does, it's got a little program in there, and it uses the point where the cursor is right now as a guess as to what the answer is, and then its little formula inside its brain creates an improved guess that's closer to the point of intersection, closer. Just press enter to get past it, and it takes a couple seconds, and you get this point negative 4.8. So one solution to this is going to be the point negative 4.8. Now that's only one solution. There was another, this one over here. So second trace, again, to get into the calculate menu, go down to intersect. Now it's asking for the first curve, second curve. Now watch, just so you understand exactly how this works. Am I on the first curve? Yes. Am I on the second curve? Yes. But if you wanted to find this point of intersection, you need to make sure its guess is close to that point of intersection. It doesn't have to be right on it, but it's got to be close to it. It's where the guess is that's important. Now, if you just move the cursor close to that point of intersection to start with, you won't make this mistake. But if you press enter, and then it's going to find that point of intersection, 3, negative 6. Okay, good. Now, just to verify that these 2 points are in fact the solutions to this system, negative 4 squared, okay, is going to be 16. Minus negative 4 means I'm going to be adding, whoops, I don't know why I added 8 there, add 4. minus 12, does that equal 8? Well, let's take a look. 16 plus 4 is 20, minus 12 is in fact 8. So that point works in that first equation. 2 times negative 4 is negative 8, plus 8 is going to be 0. So yeah, the point negative 4, 8 works in both equations. Perfect. Does 3 negative 6? Well, 3 squared is 9, minus 3 minus 12. Does that equal negative 6? Okay, well 9 minus 3 is going to be 6. Minus 12 is in fact negative 6. Beautiful. 2 times 3 is going to be 6, plus negative 6 is going to give you 0. Yes, it does. So good. Those 2 points do satisfy both equations. They have to satisfy both. Okay, and what I mean by that is they make, when you plug them in, the left side equals the right side. That's all I needed. Good. Let's take a look at this next one. In neither case, neither the quadratic nor the linear here are the equations in a position that I can enter them into the calculator really nicely. So I got to move some stuff around. So maybe here, this is equation 1, this is equation 2. So let's take a look at equation 1. Maybe what I'll do first is move that x squared over. Negative x squared plus x plus 12. And then I'm going to remove the negative. I'm going to change the sign on every term here. So y is going to equal positive x squared minus x minus 12. Okay, well there we go. There's my first equation, and it's in a form that's easy for me to enter into the calculator. Wonderful. Equation 2, let's bring over the x and the negative 18. Okay, so negative y is equal to negative x plus 18. Now I already know there's going to be a whole bunch of people out there who says, well, why didn't you just move the y? Yeah, I know. What I'm running into is I'm running into the situation where I'm interacting with a lot of students that negative in front of the y, oddly enough, seems to be less important than the negative behind the y, and I don't know why that confusion is there. When you move those terms over, that x and that negative 18, that doesn't affect the sign on the y, and I need you to see more and more examples of that. So, sorry, just bear with me. If you're already moving that over and you've got the answer, that's great. For the rest of you, I really need you to understand how the negatives impact this. It's frequently the case that if a negative shows up at a problem, we can already guess that like up to 80% of students will get it wrong. Okay, you need to be careful with negative signs. So after I've moved those terms over, the negative, when I bring it over, is going to change the sign on both of those, so I still get positive x minus 18. Okay, so now what we got to do here is we're going to enter that in to the calculator. So we'll put those over there. Whoops, I'll do it like this. So I'm going to enter in those 2 equations. So x squared minus x minus 12, and then x minus 18. Good. All right. Press graph. Oh, now look at that. See, and this is an example of one where we're going to have to change the window settings. I'm not seeing a point of intersection here. There's my x minus 18, but that's, if they intersect at all, based on how that line is drawing, it's got to be down here. So I've got to go into my window settings. I have to go below the graph, which below is a y direction sort of discussion. And I got to make that a little lower. So let's make that negative 20. Let's see what happens when I press graph now. Right now I'm seeing the bottom of the parabola. That's awesome. Ah, look at that. There's no solution. Okay? These 2 particular graphs don't even intersect, so no solution. And that's okay. I know that when that happens on an exam, that's that's not always very comforting. But that's okay. If there's no solution, there is no solution. Okay? Now let's just take a look at another question here. And just so that we're really clear on what's going on here, solve the system graph below. I'm not even given the equations here. If you look around here, there's no equations for this. So I'm not going to be able to do this by entering these things into the calculator and letting the calculator do the work. I have to know that that's a solution and that's a solution. And I need to be able to read those points off of a graph. Now, would you get a question like this on an exam, something that's as straightforward as this? Well, yeah, you would. Okay? And it might be surprising to a number of people here how often it is that students, I should say, have trouble reading points off of a graph. You would think that by the time you got to grade 11, okay, that something like this would be second nature. You've been doing this for years. But it's not for everybody. So let's talk about this point of intersection right here. Remember, you always start at the origin. So to get to that point of intersection, I go horizontally, look at the scale, be very careful about the scale, 2 to the left, and 16 up. So one of my solutions has to be -2, 16. Those are the coordinates for this point right here. I need to put parentheses around that. If you don't put parentheses here, this is just a list of numbers with there's no specific meaning here for the -2 and the 16. It's just a list of numbers here. As soon as you put parentheses around it, I know what you mean, because think about it. As soon as you put parentheses, what letter comes first? X. What comes second? Y. So you're saying that X is -2, 16 is Y. And if you don't put parentheses there, that's not what you're saying. Okay, the punctuation, if you will, okay, the notation that you use here, really important. Over here, again, starting from the origin to get out to that point, I go 8 horizontally in the positive direction, and then I'll go up 6. And again, so in parentheses, it's going to be the point 8, 6. That's my X coordinate, that's my Y coordinate. Here are my two solutions. Okay, now we're going to take a look at solving linear quadratic systems algebraically. Okay, this is really where we wanted to get to. So you're going to see that our method here for solving is going to be really similar to what you would have seen in a previous course, with just a little bit of a tweak to it. The reason for that tweak, in a previous course you would have used substitution and elimination, and they work here as well, but you've got to be very aware that you've got an x squared term that is going to show up in this system. And that x squared means that you're going to have a term in one of your equations that has no partner or no like term in the linear equation. Okay? So that's going to impact how you're going to approach this. Bear in mind also that a linear quadratic system can have 0, 1, or 2 solutions. Okay? So again, you're going to have to be aware of that. Make sure that you're interpreting your answer correctly. And once you've got the value of x, okay, and you're going to get those basically one at a time, if you want to get the y coordinate, all you got to do is substitute that back into one of the equations. And you know what? You're probably going to want to go back into the linear equation because you're lazy. Okay, putting it into the quadratic, you're just working too hard. But if you go into the linear, it's a fair bit easier. So when you're asked to solve a linear quadratic system, now we're going to take a look at a few cases here. Now, these are just suggestions. Please do not take this to be the absolute way this has to be done. We're just giving you some suggestions here. You're going to basically find your own sort of comfortable way of dealing with this. This is just some things to think about how you can make your life a little bit easier. So let's take a quick look here. Case 1. So let's say you've got both equations are set equal to the same variable. Okay, so if that's case, here's equation 1, here's equation 2. If they're both set equal to the same variable, in this case y, having it set equal to x won't help you. Okay, if you have x equals with an x squared in there, x equals, that's not going to be very much useful to you. But if they're both equal to y, then if y is equal to x squared minus 7x minus 12, and y is equal to negative 3x minus 20, that means x squared minus 7x minus 12, which is y, should be equal to negative 3x minus 20, which is also y. Okay, this is actually called the transitive property. If something is equal to y and y is equal to something else, then those two things must be equal to each other. Okay, that's how you explain that shared equality there. Now, once you've got that, notice that this overall equation, that's quadratic. And to solve a quadratic, I got to move every term to the same side. So I'm going to make this x squared. I'm going to bring that 3x over. Whoops. Okay, so I'm going to add 3x to both sides, so it'll become negative 4x. And I'm going to add 20 to both sides, so that'll be positive 8 is equal to 0. Okay? Now, I'm just going to double check that just in case I screwed that up there because, okay, whatever. That's okay. So now, I am looking for factors of 8 that are going to sum up to negative 4. Yeah, they don't exist, right? Factors of 8 are going to be 2 and 4. Well, that's not going to give you 4. 1 and 8, that ain't going to give you 4. So what we're left with here is we're going to be looking for what x is equal to using the quadratic formula. So that would be negative of negative 4 plus or minus the square root of negative 4 squared. That's going to be 16 minus 4 times 1 times 8 all over 2 times 1. So 4 plus or minus the square root of negative 16 over 2. Now, as soon as that discriminant becomes negative, oh, there's no solution. There's no solution. Huh. Well, I see I had some difficulty factoring here. Didn't know what to do, so I jumped right to the quadratic formula. Maybe in a situation like this, when I can't factor that right away, that might have been a quicker thing to do, to just check the discriminant to see whether or not that quadratic is going to have any roots at all. See, there's a shortcut. We could use that discriminant to make that a little bit quicker. Anyway, let's keep going here. Case number 2. If one variable is already solved, then what you could do is you could do a substitution. Now again, you don't have to. You could, for example, isolate the y in that quadratic and then do the same thing that we just did. It doesn't matter here. But if you know from one equation that y is equal to 2x plus 1, then if that y right there is 2x plus 1, then so is that y right there. And so this becomes x squared minus, in brackets here, 2x plus 1, and then minus 5x plus 7 is equal to 0. So this is still that same first equation. X squared minus y minus 5x plus 7 equals 0. Now I'll distribute that negative through. Okay, because that negative is in front of this expression. Minus 5x plus 7 is equal to 0. So x squared minus 7x plus 6 is equal to 0. All right, now I'm going to try factoring. But if factoring doesn't work really quick, I'm going to check the discriminant to see if there's any solution that I'm missing. So this has got to be x and x to get that x squared. This is positive, so they're both the same sign, so they're both negative. 6 and 1 here. So x is either going to equal 1 or positive 6. Okay, that factored really nicely for me. But that is not the end of this problem. Okay, because I am looking for points of intersection. So I know that x could be 1 or x could be 6. I got to get the y coordinates. Let's use this guy right here. If x is 1, 2 times 1 is 2, plus 1 is 3. So the y coordinate would be 3. I just take that x value and make that x equal to it. Or, because there's 2 possible values for x, try the 6. 2 times 6 is 12, plus 1 is 13. That might be the answer. Or sorry, I should say, that's an answer. Now, I'm going to just check to see if that works. I just used the second equation here just to grab those values here, those y values in particular. Now I'm going to double check that that actually works in the other equation because it's got to work in both here. So 1 squared is 1, minus 3, okay, 1 minus 3 is negative 2, minus 5 times 1, so minus 5. So what have I got there? I have 1 minus 3, negative 2, minus 5, negative 7 plus 7 is 0. So, okay, good. 0 equals 0. That first point works. Let's try this one. 6 squared is 36. 36 minus 13, because the y coordinate there would be 13. 36 minus 13, okay, is going to be 23. Minus 30, okay, because I put the 6 in there. 23 minus 30, that's going to be negative 7 plus 7. There it is again. Both of those points work. Wonderful. There's one other case that we want to consider here. Okay, what if everything is messed up here? So if two equations are on top of each other and all the variables, with the variables lined up, elimination could be used. Now I know it says should be used here, should be used, but again, that's your call. We are not going to dictate to you how to do this. You got to find a way of understanding this that makes sense to you. It's just that this is a suggestion here. So for example, here's equation 1, here's equation 2. I'm going to rearrange these a little bit here. Nothing is really solved for here. You just kind of got everything mixed up. So I'm going to line up the variables as best I can. So I'm going to take equation 2 to start off with, because it's always nice to have the quadratic on top. Okay? So x squared minus y plus 4x equals negative 1. I'm going to take that second equation. I'm going to line up the equal sign. So equals negative 3. Based on what I had written here with the first equation, I kind of want the y term first. So I'm going to make that negative y plus 3x. Now, I am going to eliminate the y. The reason I'm not going to eliminate the x is because in the vast majority of problems that I approach like this, okay, I'm going to have x's here, an x squared, and there won't be any x squared to cancel out with that. And so I will never be able to just eliminate the x's in these problems, okay? Because there's always going to be an x squared term that doesn't have a pair. So it's not going to work here. So what I got to do is I'm going to eliminate the y. Now, in this case, both the coefficients here are negative 1. If the coefficients were different, I would multiply the equations by whatever constants I could think of that would make those coefficients the same, so that I could eliminate them. Now, this is exactly the same thing as you would have done way back when in a previous course here. But because in this case they're already kind of set up for me nicely, I'm just going to subtract this second equation. Now watch how this works. X squared minus, well, there is no x squared term in the equation, so it's going to be x squared, basically 1 minus 0, 1x squared minus no x squared is x squared. Negative y minus negative y is negative y plus y. They cancel, which is exactly what I wanted. 4x minus 3x is going to be positive x. Negative 1 minus negative 3 is going to be negative 1 plus 3, or positive 2. So now I've converted those two equations into one quadratic. To solve a quadratic, I'm going to bring that 2 over. Okay, now I'm hoping that this factors. So I'm looking for factors of negative 2 that add to positive 1. Okay, positive 2 minus 1, does that work? Yeah. So x is either going to equal negative 2 or positive 1. Good. So I run into the possibility of having 2 points, negative 2 comma something, 1 comma something. Now let's go back up to the line, the linear function, to figure out what's missing here, or what the y coordinate is, I should say. If you plug negative 2 in for x, 3 times negative 2 is going to be negative 6. Let's bring that over. Let's add 6 to both sides. So I'm going to get negative y is equal to 3. So y is equal to negative 3. Perfect. Now try it with a 1. 3 times 1 is 3. Subtract that from both sides, so I'd get negative y is equal to negative 6. Then divide by the negative, get positive 6. Good. I got 2 different solutions here. Now, but let's see if these points actually do work in the second equation. So let's plug in the values here. Negative 2 squared will be positive 4. Minus negative 3, so this will be positive 4 plus 3, so 7. Okay, 7 plus 4 times negative 2. Well, that's going to be negative 8. 7 plus negative 8 is in fact negative 1. Wonderful. That satisfies the equation. Now let's try this one. 1 squared is 1 minus 6, okay, will be negative 5, plus 4 times 1 is 4. Negative 5 plus 4 times 1 is going to be negative 1. That equals the right-hand side. That point also satisfies that system of equations. Good. So those are my 2 solutions. Right, so let's just try doing some examples here. So this first one says solve the following system algebraically using whatever method you want. So we're going to solve a couple here doing whatever method we want here. Okay, so take a look at these two equations here and notice that they are set up. We haven't really solved for any variable here. This is kind of like one of those case 3's up above here. Actually, I like what's going on here. I'm going to take equation 2, write that out. Then I'm going to take equation 1 and write it underneath. I like having the linear below. Now I'm going to line up the terms. So y minus x minus 1 is equal to 0. I've given myself a bit of a gap here because there's no x squared term with that first equation there. But notice that these don't match up. So what I'm going to do is I'm going to multiply this line by 2 to get 2 minus 2x minus 2, and then 2 times 0 is just 0, so that actually isn't going to do anything. So for my second equation, and I'm now, okay, look, I've got the same coefficients here, so now if I want to get rid of the y, and I always do want to get rid of the y, what I'm going to do is I'm going to subtract that second equation. So 2y minus 2y gone. Awesome. Negative x squared minus nothing is going to be negative x squared. Move on to the next term. Negative 4x minus negative 2x. Okay, this is going to cause some confusion here, but negative 4 minus negative 2 is the same as negative 4 plus 2x. So it'll be negative 2x. Negative 4 plus 2 will be negative 2. 6 minus negative 2. 6 minus negative. So 6 plus 2, 8 equals 0. All right, here's a quadratic. I'm going to divide everything through by that negative because it's far nicer to work with it if the leading coefficient is positive. We're going to hope that this thing can factor nicely. Factors of 8, they're going to add to 2 here. Negative 8, that'll add to 2. That'll be positive 4x minus 2. So x is either equal to negative 4 or positive 2. Good. So now we've got two possibilities here. Negative 4 comma something. 2 comma something. Let's take that negative 4. Let's go back to the linear because we're lazy and the linear is easy. So y minus negative 4. So that's y plus 4 minus 1 equals 0. Plus 4 minus 1. So that's y plus 3. Y is equal to negative 3. Let's plug in the 2. Y minus 2 minus 1. Y minus 2 minus 1. So that's y minus 3. I'll bring that over as positive 3. Now let's just double check and see that those points work in the quadratic. Okay, so this starts off with 2 times y. So 2 times negative 3. So it's going to be negative 6. Negative 6. Minus x squared. Well, x is negative 4. So that's going to be negative 4 squared is 16. So negative 6 minus 16 is going to be negative 22. Okay. This is going to be negative 4 times negative 4 is going to be positive 16. Oh, okay, well those two terms kind of cancel each other out. And positive 6. Oh, okay, well this was negative 6. That's okay, that works. Okay, that point works. Let's try this one. 2 times y is 6. Okay, because y is 3. X squared is 2, so 6 minus 4. Okay, 6 minus 4 is going to be 2. Negative 4 times 2 is going to be negative 8. 2 minus 8 is negative 6. Plus 6 is 0. There you go. So the point 2, 3 also works. Both of those are solutions to the system. Wonderful. Take a look at another one. Now, I'm not particularly fond of something here. There is something in this particular question that should jump out at you as ugly. Let's take this second equation and multiply it by, by 3 right away. Right away. Let's get rid of that fraction. There's no point in working with it. 3 times a third is just going to be 1, so it's going to be x plus 3y is equal to 9. Okay, that's a much, much nicer equation to work with. Love it. Okay, now, what do we got here? Well, we've got this expression here over top of this one. I tell you what, let's bring the 9 over. Let's line up the terms again. So here's equation 1, 3x squared plus x minus 3y plus 8 equals 0. And then the next equation, if I bring that over, will be, I'll line this up here, x plus 3y minus 9 is equal to 0. Now, in this particular case here, the coefficients of the y, and remember, it's the y that I want to get rid of. That's the one that's I've got just one of each of those in there. Okay, that y and that y. They're opposite signs, so if I simply add those two equations together, I will get rid of those. So 3x squared plus nothing, there's no match to it, it'll be 3x squared. X plus x is going to be 2x. Negative 3y plus positive 3y, those cancel. I did that on purpose, I knew that was going to happen. 8 plus negative 9 is going to be negative 1 equals 0. All right, now we are hoping that this is going to factor nicely. Now, 3x squared can really only be broken up into 3x and x. 1 can only be broken up into 1 and 1. For this to be negative, these two signs have to be different, and then the larger product has to be positive if this is going to be positive. So that's got to be positive minus. So in which case, x is equal to 1/3 or negative 1. So let's go over here. So my two values for, the two possible points that I get here will be 1/3, comma, don't know yet. Negative 1/3, negative 1, comma, I don't know yet. All right, let's go over here. So if I plug these guys in to my equation, if I plug 1/3 in for x, I've got 1/3 plus 3y equals 9. Well, let's bring that 1/3 over. And if I do that, I am going to get, now I'll write this out because I think some people are going to have a little bit of difficulty with this here. That's going to be 1/3 plus 3y is equal to 9. So 3y is equal to 9 minus 1/3. Now, I almost always have students that run into problems here. 9 over 1. Remember, I need common denominators to add or subtract fractions. So 27/3 minus 1/3 is going to get you, now this is still 3y, is going to get me 26/3. And then I'm going to divide by 3. So y is going to equal 26/9. Because when I divide both sides by 3, it's like multiplying this denominator by 3. 26/9. Okay, now I know that's going to not strike a lot of people as really happy. I'm going to show you something you can do on the calculator to check that real quick. Anyway, if we plug negative 1 in, that's a little bit easier here. If you plug negative 1 in for x, bring that over, you're going to get 3y is equal to 10. So y is simply going to equal 10/3. Okay? Now, let's use the calculator to see if that works. Okay, I got to quit here. So let's just plug those things in. We're going to look at 1/3, comma 26/9 here. Let's just plug this into the first equation. So 3 times 1/3 squared plus 1/3 minus 3 times, now what did I have? 26/9 plus 8. Okay, now, if I've done this correctly, that should be 0. And it is 0. So that point works. Now let's try the same thing with the negative 1 10/3. Okay? So this will be 3 times, okay, well, negative 1 squared is just going to be positive 1, so I'm going to leave it. Plus negative 1 minus 3 times 10/3. Now, that would have simplified nicely for me anyway, but I'm chosen to use the calculator now, so that's not a big deal. Plus 8. And again, I'm getting 0. So I know that both of those points are good solutions to this equation, or this system of equations, I should say. All right, just a couple more questions here. This time we're going to look at some word problems. Just to show you how this works with word problems. So two numbers have a sum of 17. Okay, now I'm not specifying what those numbers are, so let's just say x plus y is equal to 17. The square of the first number, now I got to decide which of those is the first number. Let's just say it's x. So the square of the first number, watch this, increased by 5. Okay, the square of the first number increased by 5 means I'm going to add 5 to it. And then the question says equals. Okay, well, what does that mean? Well, that means equals right there. The second number. What are the two numbers? Okay. Okay, well, that's not so bad. Now, notice one of the things that might help you through this is if you recognize here that in many cases, sentences become equations. Okay? Sentences become equations. The first sentence in this problem itself became an equation. Two numbers have a sum of 17. Two numbers have a sum of 17. The square of the first number increased by 5 equals the second number. Perfect. Now, here, notice that I've got y isolated in this one. It's not isolated in this one, but it is isolated here. So I know that y is the same as x squared plus 5. So if I plug that into my first equation, there's my y. X plus y equals 17. This is equation 1. This is the first one. I've just plugged the second equation into it. Now I'm going to drop the parentheses. I'm going to reorder that a little bit because I prefer to have the x squared first. Plus x, and then I'm going to bring the 17 over. Okay? Just so that it's equal to 0, because with a quadratic I need it to be equal to 0 to solve it. Now I'm going to factor, if I can. X, that's easy because it's x squared. Now, factors of negative 12 that add to 1 are going to be positive 4, negative 3. So my solutions here will be negative 4, positive 3. So that's going to open up the possibility for a couple of points, negative 4, 3. Actually, you know what? Let's go to the x squared plus 5 here because that's going to be the easiest one to do. You don't normally go to the quadratic, but in this case it's going to be pretty easy. Negative 4 squared is 16, plus 5 is 21. 3 squared is 9, plus 5 is 14. Now, do those points work? Well, plug them into the other equation that we didn't do. What's negative 4 plus 21? 17. Yeah, that works. What's 3 plus 14? 17. Yeah, that one works. So our two numbers here are either negative 4, 21 or 3 and 14. Let's look at one more. A line passes through the points negative 4, negative 10, and 5, 8. A parabola has a vertex 2, 5 and a y-intercept of 1. Find the points of intersection of these two graphs. Okay, well, we've actually got to come up with the equations of these two functions here. So first of all, a line passes through the points negative 4, negative 10, and 5, 8. I got to get the slope of that line. So y2 minus y1 over x2 minus x1. So 8 minus negative 10 is going to be 18. 5 minus 6 is going to be 9. The slope is going to equal 2. Now, I know that that means my equation is going to be y equals 2x plus b. Either one of those points should satisfy this line. I'm lazy. I'm going to use the 5, 8 because there's no negatives there. So 8 is going to equal 2 times 5 plus b. 8 is equal to 10 plus b. Negative 2 is equal to b. Therefore, the equation of the linear function is going to be 2x minus 2. We'll come back to that in a second. Now let's look at the parabola. You know that you got a vertex of 2, 5, and it's got a y-intercept of 1, so it's going to look like that. Okay, well I know the vertex, so let's put this in vertex form. So y is equal to a x minus 2 squared plus 5. 2, 5. I know that it's got a y-intercept of 1, so it should go through the point 0, 1. Okay, so 1 is equal to a 0 minus 2 squared plus 5. Well, I'm going to bring the 5 over, subtract it from both sides. And then negative 2 squared is going to be 4. And when I divide, I'm going to get negative 1 is equal to a. So therefore, my equation is going to be negative x minus 2 squared plus 5. There's my quadratic. Now, I already know that this would be easier if it was in standard form. So I'm actually going to expand this out first before I combine those two equations. I haven't worked with a system yet where I had it in vertex form. So that suggests to me that it probably is not as useful in this form. So let's square the x minus 2 squared to get x squared minus 4x plus 4 plus 5. And if you're wondering, where did that negative 4 come from? Oh, x minus 2 squared means x minus 2 times x minus 2. You cannot just distribute this squared through to both terms. It doesn't work like that. You gotta write those out together and then distribute. FOIL, whatever you gotta do. That's where that negative 4x comes from. If you're not sure, you're gonna have to go back over older lessons and review that. Okay, the expectation is now that you know exactly where that negative 4 is coming from. Okay, if you're not seeing that at this point, it's because you've really consistently missed the pattern. Okay, because it has happened over and over and over again. Now we're going to distribute that negative through, so negative x squared plus 4x minus 4 plus 5. So negative x squared plus 4x plus 1 when you simplify it. So now this is in standard form, which is going to be much easier to work with than it would be in vertex form. And again, if you're not seeing where that negative 4 is, please, you just got to go back and review that. Okay? Now, here's my system of equations. They're both equal to y, so I'm going to set them equal to each other. And now, because the x squared term is negative here, I'm going to move everything over to the left-hand side. So x squared minus 2x minus 3 is equal to 0. Let's factor those. It's got to be x and x, and this is negative 3, so this is going to be negative 3, positive 1. So x is either negative 1 or positive 3. Okay, good. So we've got 2 points here, 2 possible points, negative 1 and 3. So let's go back up to the linear here. If you plug negative 1 into that, 2 times negative 1 is negative 2, minus 2 is negative 4. Plug the 3 in. 2 times 3 is 6, minus 2, positive 4. Do those points work? Okay, do those points work in both equations? Let's try this negative 1, negative 4. So if we plug negative 4 into that, okay, let's just take negative 4. Let's see if negative 1 makes that work. Negative 1 squared is going to be positive 1 times negative 1. So negative 1. Oh, plus 1. Those cancel. And 4 times negative 1. Oh yeah, there it is. There's your negative 4. So that worked. Now let's try 3, 4. Okay, so y is equal to 4. So this is going to be 3 squared is 9, negative 9. 4 times 3 is 12. So negative 9 plus 12 is going to be 3, plus 1 is 4. Yeah, there we go. They both work. That's the solution of the equation.